The discriminant, which is described using a triangle, is b squared minus 4ac, and it comes directly from the quadratic formula. In fact, it's the part that's in the square root. So what we're actually describing is whether or not what's in the square root is 0, greater than 0, or less than 0. And that tells us a lot about our graph. It tells us what types of solutions that we could have. So there's 3 possibilities. There is no solutions, there's 1 solution, and then there's 2 solutions. So if we use this and we solve it, we can actually tell what kind of solutions that we have for our equation. So b squared minus 4ac is our discriminant. The next little section, we're going to look at what these graphs look like in our calculator, and then the corresponding discriminant for each of them, and what this means as far as the solutions go. So if we graph this first equation, x squared plus 3x minus 4, we get this graph with 2 places where it hits the x-axis. So it hits it roughly -4 and then 1. And if we now calculate the discriminant for this, we find that we should be getting a positive discriminant. In fact, we do. We get a positive discriminant of 25, which means that we have 2 real or rational solutions. If we now look at graphing this second equation of 3x squared plus 6x plus 3, we find that when we graph it, it touches the x-axis at about -1, but it doesn't actually cross over it. So it only ever touches it in one particular spot, which means that when we calculate our discriminant, we'll end up with a value of 0. So we'll have 6 squared minus 4 times 3 times 3, which gives us 36 minus 36, which is 0, as expected. And if the discriminant equals 0, then that means that we only ever get 1 solution, which is what our graph is showing us. If we now graph our third equation of x squared minus 2x plus 3, we find that at no point does it actually cross the x-axis. So it's above the x-axis, which would suggest that we have no solutions. We can check this using the discriminant, so -2 squared minus 4 times 1 times 3 gives us -8, so a negative value, which means that our discriminant is less than 0, so there are no real solutions, i.e. it can't be factorized, which is as expected because we have no x-axis intercept. So in summary of that, what we have is 3 scenarios where we have no solutions in one solution in the second equation. In the first equation, we have 2 solutions. By solutions, we mean how many times they touch, in this particular case, the x-axis. In not all cases are we talking about the x-axis. We refer to this as the x-axis because our equation is looking at where it touches the x value. And we've got a base equation in the first place of ax squared plus bx plus c equal to 0. Because it's equal to 0 in the first place, we're looking at where it touches the x-axis. However, we can have scenarios where we're not looking at where it touches the x-axis, but instead we're interested in where it touches another graph. The discriminant will still work for this, but you have to make your equations equal to each other. So for instance, if you have your quadratic and you make it equal to your linear, rearrange it so it's equal to 0, and then find your discriminant from that, you can actually calculate whether or not you have 1 solution, 2 solutions, or no solutions. So this will follow the same process as what we've got up here, giving 2 solutions, 1 solution, and again, no solutions, based on a discriminant being positive, 0, or negative. We are going to look at examples of these cases here, so don't be too worried about them.